Hi, welcome everyone. In today's video, I'm going to show you how to estimate simple time series regression in Stata, and this is for the people who are new in learning regression analysis and econometrics. So it's not about estimating a best model, it's about how to estimate an OLS model and how to look for diagnostic tests. So I have a data of Pakistan for 30 years. There are a few variables here. So first of all, I will tell you how to arrange the data and then go towards importing it into Stata and then moving towards analysis and diagnostics and some descriptive stats. So I have this data. You have to make sure that your data is in terms of variables going across columns and here is going across rows. So this way it's a cross sectional in terms of variables in terms of wide and time in terms of long. So it's a time series data because it's only for one country. So first of all, what you have to do is you have to make sure the variable names are short without any space, so that when you go in Stata, the codes are small enough so that you can type it quickly, and make sure your names are recognizable so that you can remember what was the name. So I will insert a row and I will now write the name. So this is a here variable, this is broad money, so I will write BM. This is domestic credit, so there's no data available. So what I can do is I can remove this column because it will not be used in the data analysis. Then there is GDP, so I will write GDP short. Then there is domestic health expenditure, so HE, and education expenditure, so it is education expenditure total, so EE. Then CPI, consumer price index, then unemployment, UNE. Then there is a trade, percentage of GDP, TRD. Then there is CO2. So I try to write a name in 3 to 4 letters without any space. So it's poverty, POV, so that when I make graph, the symbols are recognizable with the full name. You can write any name, but then you have to tell in the analysis in the report that this is the short name and this is the full name. This is R&D, so R&D. This is innovation, INNO. This is institution, INST. This is quality of education system, QES. This is competitiveness index, so GCI. So these are the variables, and I will press save. So this is the data that is available. What you can do is just go to the first name of the variable, control shift right and control shift down, and then copy it, and then go in Stata, and here you can go. Here is that data editor, paste your data here. So control V, it will ask that first row is names or data. So we already know the first row is names, so I will press here. The data is imported. You have to just make sure that all the columns with the data are in black. If they are not in black, it means they are not recognized as a numerical data. If they are red, then it means it is text data or character data, so regression will not pick it up. So sometimes there is some typo error, like people write O in terms of 0, so the data becomes text. So if there is a problem that any one of the variable is red, you have to go and look at the data. If there is any English character or non-numeric character is there in the data, you have to remove that and then import it again. So this data is loaded. We'll start with describing data that it is a time series data, otherwise Stata will not recognize it as a time series data. So the command is TSSET year. So we are saying that it is a time series setting with respect to year. So the year variable is the reference variable for us. It tells us how the data is changing across time. So it's a time pillar. So we say that set the data time series setting. So time series set the data according to year. When I do it, it says that yes, it recognizes that it's from 1990 to 2019 and there is no gap in it. It's 1 year change. So every year there is only 1 year changing. So data is loaded. Now what we can do is, first of all, we have to describe the data. So I will give you a few commands that are very useful in giving descriptive stats. We'll start with tab stat. So after tab stat, you write variable names like BM, GDP, HEE, CPI, UNE. So you can write all the relevant variables you need, and comma, then write stats. Then you tell what statistics you need. I need sample size, I need mean value, I need median, I need IQR, interquartile range, I need SD, I need skewness, I need kurtosis, I need the P percentile 25 value, percentile 75 value. I can also need a range. There are many other things you can go and search, right? Help, tab star, and see what are the things it can give. So when you press enter, it says that there's an unknown statistic, so there's a spelling error. So I will write page up. So spelling CUR, so it has given. So this way we have a descriptive stats table. Here the variable names are shown and the statistics are here. You can take a screenshot, or ideally just type it yourself. People, the journals or the reports prefer that you type the values yourself rather than taking a picture. Then you need a normality test. So what I can do is I can page up, remove the extra tests, and then write the variable that you need. So all dependent and independent variables. Then I will write SK test. So it gives me normality test. So the p values are shown here. Other than last two variables, above four variables are normal. There are other ways that you can check normality. That is S-Wilk test. So it also tells that first one is normal, other are not normal. There's one more, S Francia. So this test give you, so second one is normal, other are not normal. So there are three ways, and there is another way that you can draw a histogram variable one by one. So I take BM with norm and theme, scheme, SJ. SJ is for Stata journal. It makes that graph in grayscale so that you don't have to worry about printing the graph in color print. Norm is for estimated normal curve, and BM, it will create a histogram of BM. So when you do it, it will show us a graph where we can check for its normality. So here you can see that the line is for normal curve and the curves bars are for histogram. You can see that it's representing it close enough, but it's this bar is little bit on the right, so it looks like it has a long left tail, so it looks like it's left skewed. Otherwise, and when you have a graph, you can add more detail, like if you press this button, Stata graph editor, it will, and you can add title, and you write histogram of BM. So when you add it, graph will be here. You can add more details like title on the y-axis, which is already there, title on the x-axis. You can also add a subtitle or a caption. So in a caption you can say that it's a source, author, instruction. So source is there. So this way then you press copy and paste in your Word file. This way you can make graphs. Another way is, because it's a time series data, you can add a line chart. So for that you can just write TS line BM. So it will give a time series line chart, and you can edit it and give more details in it, like title or full name on the y-axis. You can also tell him that show all the years by going here and double clicking the y-axis. So it says number of clicks, so I can just make it 30 because I know it's 30 years data. So I will just say 30. So it is showing. So now it's too big, so it's not readable. What I can do is I can go and label properties and reduce its size from medium small to very small and apply. And okay, it's now very small, it's not readable. What we can do is make it a little bigger, small, and rotate it horizontal to vertical, this way. Okay, and apply. So now you can see it's readable. This way you can have graphs here. Other graphs then you can do is that if you want to compare two variables. So the best way is to do a scatter, so BM and GDP, so there will be a scatter plot, and this way you can say that they are positively correlated, and you can add full names and title using this button. Then if you want to compare the time series lines, so it becomes complicated. This the graph is called two-way, and you write line BM here. So there's one graph and then line BM GDP here. So the problem, so this way there will be two lines, but the units of GDP are too big. So what you can do is you can go down and say it's y-axis 2. So this way it goes on the second y-axis, and because it's now colored, what you can do is close it again, page up, and write comma scheme SJ. It will become black and white. Now you can just add labels by pressing this and edit the graph. There are two y-axes, so you can label it properly. Add a title like comparison between BM and GDP. So this way you have this graph, so you can just copy it. So this way you can describe your data properties. Now since we already see the graph, you can have a numerical comparison using a correlation plot. So you can go up, first of all bring the variables names here, and then first way is to do a correlation table. You can tell, and if you want its probability values too, then we can do is PW core. You can bring the name and its pairwise core, and then just come after comma write SIG. It will give you the correlation values and its probability values. So this way you can see. And there is another way with the detailed, and it's a big graph, and if you have few variables you can use that. It's called scatter matrix. It's graph matrix, I think. So this way it will show you all the variables in a scatter plot. Variable names, you can also edit it, add a title, edit the variable names, and then this way you can compare all the variables. Okay, so this is the way you are comparing the variables with each other. Now we are going towards regression analysis. So the command is reg, and then you add the variable name. So I will select the variable names from here and change the command, it's reg. So its regression is done. Now you can see that other than two variables, all are significant. Regression statistics are here, coefficient results, p-value, standard error, t-values are here. Ideally you can see the GDP coefficient is very small. This may be because you can go up and see the range values. So the range of BM is only 24, and range of GDP is very big. So ideally, and if you compare all others, the GDP range is very big, so you have to generate a new variable which is the log of GDP, so that the range is shrunken and it is comparable. So I will write gen LGDP, which is equal to ln GDP. So, and then when I do the regression, I will do the LGDP. So this way now you notice that coefficient value is smaller enough, and this is the regression result. Now we need to do the regression diagnostics. So first of all we can do is that Estat DW Watson test. So it is 1.45. It ideally it should be 2. So or 2, not above 2 or not below 2. So its range is between 0 and 4. So it is less than 2, means there is positive autocorrelation. Then we can do Estat het test. So this is heteroscedasticity test. It is probability value is insignificant, so it is indicating that there is no heteroscedasticity. Then Estat OV test, it is also insignificant, means there is no omitted variable bias, means none of the square variable is missing from the data. Then there is another called that Estat VIF. So all the VIF are, so according to Gujarati econometrics, if the VIF is above 10, there is a hint of autocorrelation. So first three variables are autocorrelated, but since it's a time series data, it's likely that the variable will be autocorrelated. So what what we can do is in time series we allow to a certain limit, and then we check it after the complicated model, not in the basic model. Then we can also check for the normality of the residual. So we estimate the residual using regression. We go in post estimation, prediction of residuals. We write residuals, and we write the variable name as residual. So the new variables is made that its name is residuals. So we do the SK test residual. So it's normal. So there's the data is normality. Data is normality. We can also do it using another means like hist residual norm. So you can look at here that it is almost following the normal curve. There are other tests called check for detailed. So you can detail problems like when you get look for outliers. So that is leverage value test. So when you make this graph, so it looks for presence of outliers. So any dots there which are away from here or here, these are showing that there is a hint of outliers in the data. So when you go and edit it, you can also uh, give numbers in the graphs in the options. If you go back, and then you can locate which one is the has a problem. Then you can use this graph, is augmented variable graph, and you select a variable like which is LGDP. You can check if it has a non-linear effect or not. So it is plotting GDP with residual plus augmented component. So I noticed that the dots or lines are following same pattern. It means that the GDP does not have a non-linear effect on the dependent variable. So this way you can rule out any non-linear effect possibility. So this is, and you can do it for all other variables. I can go back again and show you in the statistics, linear, diagnostic, augmented variable plot, and then you can change the variable. Like I can select some other variable that is already used, maybe HE. So if you plot it, it's straight line, but it's very scattered. It is because that this variable was already insignificant. So HE was insignificant. So this way you can do the diagnostics in the regression analysis. Ideally, there will be problems in the data because it's a time series data, and advanced models are recommended. And then in the specification tests, there are some other, like you can test for arch effect. This is used when the data is high frequency, like it's a quarterly or monthly data, so it's insignificant, there is no arch effect. And there are other tests. Let me see if we can locate for more. There is test called you can summarize the sample, and you can get information criteria that is useful. You need a kite value or Bayesian information criteria or log likelihood, so they can be helpful in comparing other models with different lag values in the model. And let's see, there is another test called Durban alternative tests. It can be used if there are lags in the data. So it is saying that there is no autocorrelation. Then what you go for other tests, let's see, VF is done. Then effect size can be used for, it can give you R square for each variable. So this is overall R square 0.79. If you go in the regression, it is similar to R square 0.7975. You can see it here. Now it is telling us the contribution of each variable. So GDP has the highest, EE has the highest contribution, then there is GDP, then UNE, then this one. So HE has the lowest contribution, mostly because it's insignificant. So these are the uh, tests that you can check for the regression analysis. Most of them are applicable in any type of regression, in simple regression, but like Durbin-Watson test, it is only applicable for time series. So my example was for time series, but if you have a cross-section data, you will not be able to do the autocorrelation test. So for the cross-section data, you can do the Durbin-Watson test, but for that you have to install another new test that's its name is LMADW. So the method is SSC install LMADW, and when you press it, it will access online and download the new module. And its command is similar. What you can do is go to the regression command doing page up, or type it again and remove reg and write LMADW, and then lags run. So it will give you the Durbin Watson value for even for the cross sectional data. So this way you can do the diagnostics for time series regression. Thank you very much for watching.